beginning chemistry, I'm going to go over some things that you need to know. First of all, we talked about scientific thought, and we looked at the 6 pictures with Hedgeman earthquake lake. Scientific thought is supposed to be unbiased. It's supposed to also be open to new evidence, and it utilizes observations in order to attempt to derive an explanation. Even when they have the explanation, they are still willing to look at new evidence to see if it supports or counters the previous explanation. If it counters it, then they're trying to look at it to see, does it explain something better than the way we have it, or do we put this in the hold stack until we have more evidence? Then we looked at a clip over Mr. Bean, and we looked at things that should not happen in a lab. And we also looked at the fact that you should never do anything without lab supervision. Basic safety materials. Graphing. I showed you this graph, and I asked you to tell me what was wrong with it. A lot of you missed the simple fact there's no title. Yes, the axis is labeled. Yes, it's straight on. Yes, you can read what's going on there. But the average house prices of where? Where are we talking about? You will lose points on your tests, on your lab book, for not putting titles on your graphs. So what about this one? Again, this one has no title, but this one also doesn't have the axis labeled. You must have the axis labeled and titles on there. That helps us understand what data you're giving us. Now this one was a little bit trickier. You see, yes, a lot of you picked up on the fact there was no title. A lot of you also saw that there were no numbers on there as well. But the problem with this one is it's misleading. It's been angled so you think that the red bar is larger than the blue bar. It's not. So don't angle your graphs either. Errors. I'm expecting you to tell me where your errors derive from while conducting labs. You're expected to be able to figure out, did you have a measuring error? Did you not get the correct number because you were off on the percent error and whatnot? Or maybe it was a device problem. Maybe your device malfunctioned while you're working it, and that's the reason that you have an error. A lot of times it's our measuring devices. Either the weighing scales are not calibrated, or you're using a meter stick that the end of it is slightly worn down so you really can't see zero, and you should have been measuring from the 1 to the 2 rather than from the end, which is gnawed off a little bit. So that's usually where those come from. Also make sure if you're using triple beam balance or the centigram that you do calibrate it before you begin. And on electronic scales, make sure that you zero it out to make sure that you get the mass of the substance you're weighing and not the mass of the substance and the weighing paper. Significant figures. An easy saying on this is remember that you're only as precise as your least precise measurement. So, if you're measuring with a device that only goes out to the 100th, you can only record to the 100th. Even if you have something else that's recording to the 1,000th, it doesn't matter. Your least precise is the one that records out to the 100th. Precise and precision are two words that I expect you to know. They are related to one another. It basically means how close your measurements are to one another. You want your measurements to be close within range. For example, if I was weighing something and I got 25.0, 24.8, and 25.2, those are all within range. However, if I had one that was all of a sudden 27.2, I would call that an outlier because it's well above the other measurements. The other measurements are fairly close to one another. And an outlier can also indicate you have an error. So go back and look at your outlier and see, did you misweigh something? Did you forget to tar out the weighing paper and that's the reason it's off? Or is there just something else going on? Accuracy or accurate refers to how close you are to being exactly right or bullseye. So sometimes I'll give you accepted value and that's what you're going for. That's called accuracy. If you get right on the dot, you're accurate. Now in your formula chart, you will find rules for significant figures. This is on your star chart. Non-zero digits and zeros between non-zero digits are always significant. So what that means is, if you have numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, those are all significant. If I have the number 101, that zero is significant because it's trapped between two non-zero numbers. Leading zeros are not significant. Okay? So if I have 0.1, that zero is not important. I can simply move the decimal behind the 1, and now I have 1.0 times 10 to the negative 1, which is what the number is. The 0 is just a placeholder. Zeros to the right of all non-zero digits are only significant if the decimal point is shown. So let's take that example again. If I have 0.10, that 0 that is behind the 1 is now significant because you're saying you measured to that point. Okay? That tells me how accurate your stuff was. However, if I have 100 and no decimal point, those zeros are not important. The decimal point traps those zeros and makes it important. So if I had 1.100.1, obviously those zeros are important. Okay. Qualitative and quantitative are two words you should also know. Qualitative is referring to the quality, color, texture, smell, descriptive terms, and are not numbers. Quantitative has an N in it. Therefore, it means numbers, 1.88 centimeters. Conversions. So let's convert 1.67 inches to centimeters. First, I start with my quantity, 1.67 inches. I place it over 1. I call the 1 a safety net. It's just to help line it up so you know what needs to be multiplied and what needs to be divided. My conversion factor between the two is 1 inch equals 2.54 centimeters. So I'm going to put that next in parentheses. The inches will now cancel out because there's 1 on top and 1 on bottom. So now I'll do 1.67 times 2.54 divided by 1. And I'll get 4.24 centimeters. The next one is 3.6 meters to kilometers. I don't want you moving the decimal. I want you setting it up so I can get you ready for stoichiometry. So we have 3.6 meters over our safety net of 1. My conversion factor is 1 kilometer for every 1,000 meters. And it equals 0.0036 kilometers. Scientific notation. So let's say I want to convert this to scientific notation, 189.07. I have to have in the lead a whole number. So I'm going to move my decimal over. So it becomes 1.8907 times 10 to the second because I moved the decimal from the 9 in front and in front one more time. So look at the next one. 0.000089. I moved the decimal to be between the 8 and the 9. Since it's decimal number, I know I'm going to have a negative. Your answer should be 8.9 times 10 to the negative 6. Last one, 1.35 e to negative 5. Now, that is the same as 1.35 times 10 negative 5. Both mean the same thing. On a calculator, it will produce an e. It won't say times 10. So I move the decimal. It's going to be a decimal because it's a negative number. I'm expecting that. And I get 0.000135.